Hi, this is the Rainforest Connection team at Grand Valley State University. This is our senior project video. My name is Joe Gibson.
My name is Kalee Stutzman.
I'm David Adlof.
I'm Jesse Millwood.
So Rainforest Connection is a nonprofit that's based out of San Francisco, California. And essentially what they do is they put Android cell phones in a box, they connect it to solar power, and they put it up in the trees. And essentially what they're trying to do is they record audio, and then they analyze that audio either on the phone or on the server, and they can detect the sounds of chainsaws, gunshots, car engines, motorcycle engines, etc. And they can relay that data to ground troops and other people that are going to come in and try and stop illegal deforestation and illegal logging.
So what the Rainforest Connection didn't have was the ability to take local measurements around the device and be able to relay those back to the server so that they can see how well certain devices are performing, or why or when they may fail due to temperature or humidity. So what we provide is temperature, humidity, input power and output power measurements that we relay to the phone over the USB port.
In addition, we also have battery charge status indicators and fault indicators on the batteries, so we can tell whether they're charging, have charged, or are in some sort of temperature overloaded fault state.
So this project was split into two portions, one being the electronics portion and the other being the mechanical portion, involving an enclosure for the device and a frame in order to attach the enclosure to a tree. Now, what they are currently using out in the field is a small Radio Shack enclosure that they place the phone and batteries and hook those together. And so what we needed for this project was a larger enclosure to fit all the added components for the electronics. So this is a polycase enclosure made from polycarbonate, and it's been modified for adding a heat sink for thermal dissipation from within the phone battery itself. And here you can see a frame was constructed around the larger enclosure. This prototype incorporates some of the previous frame pieces that were adapted for size. The actual pieces will be made with a 3D printer to actual required size. And this piece on the back will be used to screw the device into a tree for an easy installation.
So on this design we included two battery charging circuits that are designed to each charge a dual cell lithium-ion battery. And right here we can see the current that's being drawn by the circuit to charge the batteries right now. And it's currently towards the end of the charge cycle, so that's why it's just drawing very little current.
Okay, so there were basically two revisions of the board. This is the first revision of the board, and as you can see, it's quite large. It's actually larger than the enclosure itself. And what we basically did was we thought that we would first include a larger enclosure and mount the cell phone to this copper pad here, and on the back we would have a heatsink, much like the heatsink that's on the enclosure, and that would protrude through the back of the enclosure. We decided to move to a more modular approach, and so that's why you see that there's these two boards here. These are obviously unpopulated, but we have this board here, which is the MPPT board, and this manages all the solar panels and make sure that we get the most efficiency possible out of each panel. And this board, which is, you see here, connected to the battery, this board includes the microcontroller and the other surrounding components that charge the batteries, charge the phone, and allow us to send sensor data to the phone.
Our second board also features a microcontroller, which we use to collect diagnostic information for the Rainforest Connection devices. Our board includes a temperature sensor, a humidity sensor, and battery charge status, and all of those can be fed through the microcontroller over USB to a phone.
All right, so these are the solar panels that we're using on this device, as you can see on the prototype device there. And essentially these panels are provided by Rainforest Connection. These panels are made from 3 strips, and these strips are actually the byproduct of manufacturing. They're just not aesthetically pleasing to the company, so they chop them off with the beveled edge, they throw them away, and we're able to use them in our design essentially for free. And these panels work in such a way that they actually perform much worse under direct sunlight, but yet they perform much better when there's specks of light, let's say through a tree canopy, which is very important for our project because we don't typically get direct sunlight. Part of the board that sends data to the phone includes a microcontroller to actually read the sensors and send it through UART and ultimately through USB to the phone. And so we've written substantial code for that microcontroller. And that code is hosted on our GitHub repository. It's all open source code.
So in the end, we were able to provide electrical enhancements to each individual device that Rainforest Connection can use. There are more revisions in the future to make these more robust, but right now we've provided basically a proof of concept.
So in the end, we were able to make the boards modular. We were able to add diagnostic capabilities to the boards and increase the efficiency of the electrical components, the electrical regulation circuitry on the board. So ultimately, Rainforest Connection now has a device that is able to make better use of the solar panels, is able to make better use of the power that they draw, and also is able to send sensor data to a phone, which could then be broadcast to a server.